trigonometry. So much of this should be already prior knowledge. You'll have seen at GCSE. So you'll probably know your sin, cos, tan. The triangle must also be right-angled in all cases if we're going to use this rule. The hypotenuse is going to be opposite to the 90-degree angle, and depending on where the angle that we're trying to figure out is, there's going to be the adjacent next to it and the opposite, well, opposite of it. And then if the angle was here, then they would swap around like this. Okay. Now, there's the different formulas. So if you're trying to figure out sin C, you'll use opposite over hypotenuse. Well, not if you're trying to figure out sin C. Depending on which angles you know, you're going to use a formula or another. So if you know your adjacent and hypotenuse, if, for example, the adjacent is 3 and the hypotenuse is 8, and you know it, then you would use cos. And then same with tan, okay? So this is knowledge from GCSE. Pretty good to revise it as well. As an example, in this triangle, we have the hypotenuse and the opposite, as you can see. So we're going to use sine. We're going to use this formula. Now, using this formula and doing the working out, we end up with this as the final answer. Sine to the minus 1, 4 over 18. 4 is the opposite, 18 is the hypotenuse, and the answer is 12.8 degrees. Okay. Looking at elevation and depression now. So have in mind that I'm not showing you many examples here because this is mostly revision from GCSE. And these videos are just to like give you a quick summary of what you've done in class, a quick recap. So you shouldn't only be using these videos, obviously do a lot of practice questions. These videos are just like quick insights to perhaps help you understand certain things. Obviously I'm not a teacher, so yeah, let's look into the next topic. This is pretty simple, but you definitely need to know it because if you don't, you're going to lose 4 or 5 marks on your exam. So first, have in mind there's always going to be an object at the bottom, an object at the top. It can be a bird, a plane, a kite, Superman, doesn't really matter. And the object can also be whatever. This can also be a cliff, not just a building. So just have in mind there's a component here, a component up top, and one in the bottom. So firstly, there's the angle of elevation here that makes up a right angle triangle. Ignore this right here. We draw a second line that helps us represent the angle of depression. And there's also a second angle of elevation, which goes from here to the object up top. Having this in mind, we can draw another line, and we have 3 different triangles here, all of which are actually right angle triangles, okay? So depending on which sides you know, you're going to do different things. You're probably going to be asked for one of these angles, okay? Or you might be asked for the whole length, the whole distance between the 2 objects. Just have in mind these are the 3 triangles you can make and the different angles around here. Next topic, so we've finished these 2. Let's have a look at the 3D shapes, the plane and the angles that we're gonna have to figure out. In 3D shapes, cuboids, whatever, there's always gonna be a plane. So in this case, the plane GHEF is named after the letters that make it up, the different points. It could be GFEH, the name doesn't really matter as long as all the letters there that make it up are in the name, okay? Same with line AH or HA, doesn't matter again. Now if we draw different lines, we can end up with a right angle triangle that's gonna allow us to do the sin cos tan that we've seen before, in case we're asked to figure out certain angles, such as the angle between the line HA and the plane right here, the surface. Now don't confuse this with, for example, if we had line EA instead, this angle right here would not be the angle between the line HA and the plane. It's not the same thing. Now, looking at a question, so if we were asked to find the angle between line BE and the plane, let's have a look at what we would do in this case. Difference between finding the line BE and the line HA. Well, not much really. The angle is still going to be between the line and the plane. Remember to draw a line between the two edges to make your triangle. That would be it. So all you need to worry about in 3D shapes is to draw the right triangle and figure out the right angle, because the calculations are actually the same as in any other question that involved a 2D shape. It's just the sin cos tan that we know of. I recommend that you draw the 2D shape from the 3D shape. So this is actually the exact same example that we saw earlier in the video. So yeah, as I said, all you need to worry about is identifying the triangle and the angle. Imagine you were given a pyramid, a shape like this. How would you identify the triangles and the angles? So first, draw a line in the center, from the center to the top. Then draw lines like this, and you'll see that you have made 4 right-angled triangles. So you can do your sin cos tan using this, and again, draw the 2D shape from the 3D shape. So for example, my drawing isn't very good, but this would be one of the triangles in here. Also have in mind that these 4 triangles are the same. Okay, they're the same because this shape is even, it's equal. And you can also draw triangles here at the plane, which are also right angled. Okay, if you divide these into pieces again, they're all going to be equal as well. Last topic, bearings. So we've done all of these. This topic is also pretty simple, but if you don't know it, you can lose a lot of marks in your exam. So it's very important to revise these mini topics, even though they're easy, because they can get you off guard. Most important thing, bearings are measured clockwise from north. Okay, remember your compass directions. North means up top. So if we have 2 points, A and B, this angle right here, this bearing right here, 228, would be the bearing of A from B. Okay, so A from B, it comes from B, 228, and it is clockwise. Similarly, if we had this angle right here, 48 degrees, it goes from north to the line, and this is the bearing of B from A. Okay, and it goes clockwise again until reaching the line. This X right here, remember that a full circle is 360 degrees. So X would be 360 minus 228, which gives us 132. This is important in questions as well. Let's look at an example journey. So bearings can be asked in the form of a journey that someone's going to do. So for example, Lou, she starts at S and she wants to end at R. To do this, she jogs 2 kilometers south, remember your compass directions, and 3 kilometers west or to the left. And we can use this to draw another line that makes this a right-angled triangle, which we're going to use. So if the question involves bearings, they will probably be mentioned. And so we're going to draw our north line, and we are going to, well, we'll see that this is 180 degrees. We might be asked to figure out angle X right here. And so we're going to need to do some sin cos tan as well. So imagine the question is find Lou's bearing from her starting point. So her starting point is S and R is the ending point. So if it asks you to look at it from her starting point, we're looking at it from S to R. Okay, so we're figuring out this right here. We already know that this is 180, and so we're going to do sin cos tan to figure out angle X, and we're going to add them together as you can see here. Okay, hope that makes sense. So doing our calculations, we're going to use tan in this case because we have the opposite and the adjacent. We don't know what the hypotenuse is, but we don't need to either. So it's going to be 3 over 2, opposite over hypotenuse, which gives us 56.3. And so we can use this here to give us an angle of 236, and that would be the correct answer. Always rounded to 3 significant figures, of course.